Hey, I'm full deck.
And I'm missing a few cards.
Today's going to be a good day, Missing,
Why is it going to be a good day, FullDeck?
because today we get to solve another Family Day Out puzzle by Maggie and BremSter.
But wait, this isn't an outside clues puzzle.
Oh, no, it's not.
Oh,
She's mixed
that's
it
a
up
shame.
on us. I know.
I was enjoying the outside
I
clues.
was too, but I'm sure it'll be a good puzzle anyway. So this is Topsy Turvy. We've got Topsy Turvy by Maggie and BremSter. And let's see, what are the rules? We've got normal Sudoku rules apply. So in every row, in every column, and in every 3 by 3 box, we need to place the digits 1 through 9 without repetition.
Digits placed on an arrow must sum to the digit placed in that arrow's circle. So, for example, those could be a 1, 2, 3 with a 6 in the circle.
Okay. And then it does not say here, but typically in Arrow Sudoku, you can repeat digits along an arrow. So these two cells could be the same.
In fact, on this one, you're going to have to because of the next rule.
Oh my goodness, look at that. Digits on a gray palindrome line. So these lines read the same in either direction. So digits that are the same distance from the end, for example, those two are at the end, are going to have to be the same digit. Those two will have to be the same digit. Oh, this is going to be fun. All right.
Shall we restart the timer?
I think we should restart the timer. All right. We'll restart our clock.
And let's give this a whirl.
Let's give it a whirl. All right, let's see. So I do rather like this line because since these three digits are all in the same column, they have to be different. So the smallest they could be would be 1, 2, and 3 for a total of 6. So the circle on that arrow has to be at least a 6.
And then on the palindrome, we can't have higher than a 6 because that would
Right.
break the arrow.
But since this is a palindrome, that digit has to be the same. And the least we could add here would be a 1 and a 2. Yep, I agree. So these do have to be 6s.
And a 1, 2 pair on the...
A 1, 2 to complete the arrow. Now we're looking at this arrow here. That sum then is a 9.
Let's place the 1, 2 at the other ends of the palindrome.
Yes.
To keep track of that.
So this palindrome, those two are equidistant. So that's the 1, 2. And for this palindrome, that's a 1, 2. We also get a 1, 2, 3 on this arrow, but this cell sees both 1 and 2. So this is a 3, and we get a 1, 2 pair, and that's because these three digits sum to 6 in the bulb of the arrow.
Okay, I have a deduction.
It's going to be a question, isn't it?
What can we say about the palindromes on row 5, column 6?
Row 5, column 6.
And row 6, column 6. And what does that say about the arrows?
Well, I'm not sure. I think those are two separate things, but let me just take this one first. So row 5, column 6 is part of a palindrome. So these two digits will be the same, which means that this is going to have to be even.
And in fact, they have to be either 3 or 4 because that can't be bigger than 8. So that's either a 6 or an 8 in the circle.
Right. So this cell in particular cannot be a 1 or a 2. So it has to be either a 3 or a 4 because since it's doubled, 5 would be too big. Yes. So these are 3, 4. I agree. And this then is either 6 or 8. It's because these two are the same. It's either 3 plus 3 or it's 4 plus 4. We get something similar here, but not quite as powerful because these could be 1, 2s.
They can't be 1s because that would place a 2 in the circle, and that would conflict with the 6 arrow.
Indeed. So this is though 4, 6, or 8. It is doubled this, and so these are 2, 3, or 4. Now, what else do we get then?
So the arrow with a circle in row 7, column 2.
Row 7, column, this one.
Yes, that is at least 4 because it has to be at least 3 in the bend in the arrow because it sees 1, 2.
Okay, this is at least 3. Yes, and this is at least 1. So that's at least 4.
So the palindrome
gets
is at least
repeated
4,
here.
and so we get 7, 8 on the circle of that arrow.
Okay, so we got lots of going. Let me step back through your logic, revoice your logic, and see if I'm following and if we're in agreement. So this cell right here, because of the column and the box, has to be at least a 3, but it can't be a 3 because of the palindrome. It would put it in the bulb of a circle, and this cell is at least 3 because of the 1, 2 in the column. So this cell, which has to be the same as the circle and the arrow, is at least a 4. So if it were a 4, we'd have 4 plus 3, we'd get 7 in the circle. It could be a 5. 5 plus 3 gives us 8 in the circle. It can't go any higher because there's already a 9 in the arrow circle up here. So this is either a 4 or a 5. So if this is a 4, it has to be made up of 3 and 1, and it has to be in that order. If it's a 5, it could be 4, 1
or 3, 2.
in either order. So we could have 1, 4 in either order.
No, we couldn't. There's a 1 in the column already.
You're right. It could not be. Let me go back. Let me go back on that. So if it's a 5, it's either 2, 3 or 1, 4. If it's 1, 4, because the 1's already in this column, this would be a 4. That would still be a 1. If it's 3, 2, with the 1, 2 already in the column, the 3 would be here and the 2 would be there. Okay, that took a while, but that's nice logic. That's really fun. I like the intricacy of deconstruction there. We now have 1, 2 pairs all over the place. 1, 2s, 1, 2s. Oh!
What? I have a deduction.
I have a deduction too.
Okay, ask away.
What does this pair of 1, 2 pairs do for box 5?
It curtails the arrow quite substantially.
It does.
Which is going to change the circle.
Do you want to be more specific about that?
8. Well, the circle in row 8, column 8 can no longer be an 8.
Okay, you're going way past what I'm seeing. You're like 7 steps in logic down the road.
I'm wrong because that's not on the palindrome.
Okay.
Forget
Okay.
that.
So what I'm seeing is that because of the 1, 2 pair in this box, we cannot have 1 or 2 in those 3 cells. Because of the 1, 2 in this box, we cannot have 1 or 2 in any of those cells, which means that 1 and 2 both have to be in row 6 in box 5. They cannot be in column 4.
Very nice.
So this right here is a 1, 2 pair.
In fact, it's a 1
and
2.
This can't be a 1 because we had already ruled that one out. So this is a 2. That's a 2. That's on an arrow, which makes this a 4. The 2 places a 1 right there, which places a 1 right there. And I'm quite pleased with that.
Very nice.
So, yes. Oh, and this 1 now looks up, and we get a 2 there and a 1 there. Those are both on palindrome, so we get a 1 and a 2. The 2 looks across, we get a 1 and a 2 there.
The 1 in column 4 looks down.
The 1 in column 4, looks down to a 2 right there.
A 3
so that
and a 5.
has to be a 3 with a 5.
And a 5.
And a 5. And so this 2 and 3 on an arrow sums to 5. The 5's on a palindrome, so we get the 5 there. This 5, 2, 1 is on an arrow, so the sum there is 8. Wow. Okay. Now what? Well, these cells C 1, 2, 5, 6, 8, and 9.
So 3, 4, and 7.
3, 4, and 7 are the only possibilities left, because anything that is seen by this cell, anything that this cell sees, this cell also sees because of the palindrome.
So in box 1, 1, 2, and 3 are all in rows 1 and 2 and columns 1 and 2.
See, 1 and 2 can't be there and
3.
can't be there. 1, 2, and 3 are locked out. Yes, so 1, 2, and 3 are definitely all up here.
And the circle can't be 5, 6, 8, or 9.
Cannot be. It sees a 5, it sees a 6, it sees an 8 and a 9, yes.
So it's 4 or 7.
Yes. So if it's 4,
it's 1, 3.
It's 1, 3. If it's 7, we still have, it could be 1, it could be 1. Let's mark possibilities. If this is a 4, then we would have 1, 3 in either order along the arrow. If it's 7, it could be 1 here with a 6. It could be 2, 5, and actually I don't think I want to mark this. That's too many possibilities. That's just going to be confusing. I'm not even sure I like the corner marks for the 1, 2, 3.
Okay, let's get rid of them.
We just need to remember they're there.
Yeah.
So what can we say anything about the 5, where 5 and 6 are? 6 is up here somewhere.
And 5
and
is
5 is over here somewhere.
Maybe put those in replacement for the marks.
Yeah, I think the 1, 2, 3 is just confusing, but we'll corner mark the corner mark the 5s. Corner marks are telling us that these are the only locations for 5 in this box. And sixes can't be in any of those cells, so sixes have to be up there. So let's see.
So the arrow in box 3.
Box 3, this arrow.
Yes.
Yes.
In column 8,
That's
it has
at
to
least
be at least 5. And at least a 3 in column 7.
So this is at least
No, it's at least a 4. It is a 4 and 5 pair.
Oh my gosh. Okay, yes. So this cell right here sees everything in the column. So this is at least a 5. This cell sees 1 and 2 in the column 3 in there, so it's at least a 4. And that's also the most they could be, because 5 plus 4 is 9. That takes 5 out up here. That was a nice spot. And this 4 looks down and gives us 3s on this palindrome, which makes this a 6.
And we've got 2, 4, and 6 in the box.
And so what's left in the column are 7, 8, and 9. Okay, yes, we've got...
So...
Wait, but which box? 2, 4, and 6 are you seeing?
It was just an observation. Okay. It was not a...
This looks powerful. This palindrome, the cells see 1, 2, 3 in box 5, 4, 5, 6 in box 3, and 8 in row 3. So this is a 7 or a 9 on that palindrome.
How about the palindrome in the bottom right?
This one, yeah. So this palindrome, they see 1, 2, 3.
Doesn't see 4.
Doesn't see 4, sees 5, sees 6. Doesn't see 7, and doesn't see 8, I think. I think those are 4, 7, 8. They see 9 in the column. Okay. Now, this is either 7, 8, or 9. This cell is at least a 5. And so it is, in fact, 5, 7, or 8. Sees 1, 2, 3, 4, and 6, and couldn't be a 9 on the arrow. We don't have a 2 or a 3 available, so we have a 1 or a 4 available only for this cell. If we get to 5, then 5 plus the minimum here is more than we can put in a single cell. 1 could go with 7 to make 8, 1 could go with 8 to make 9, and 4 could go with 5 to make 9, but there's no way to make 7 here.
Yeah.
3 has to be in one of these 2 cells in the box. I'm seeing a 3 in this row and a 3 in this row. So 3 in box 4 has to be in one of those 2 cells. This is at least a 4. Now, this might be the place to play. Let's look at this for a minute. If we had, we've got 1, 2, and 3 already used up in the box.
And the circle can only be 7, 8, or 9.
Yes. So we couldn't put a 4 here because that would need a 5. Couldn't put a 5 here. That would need a 6. We could put a 6 here with a 7 in the circle. We could put a 7 with an 8 in the circle, or you could put an 8 with a 9 in the circle. 1 in box 8 cannot go in these 2 columns, so does have to be in one of those 2 cells. So 4 in box 5, could it be in any of those?
So let's look at the circle in row 5, column 2.
Okay.
So I think it's quite restricted. So that is at least
a 4. So it could be 4. I'm going to be naive here. I'm just going to go with this rate. It could be 6 and it could be 7. Cannot be 5 because it sees 5s, and it cannot be 8. So 4, 6, or 7.
So
the most that this could be is 5, because 4 plus 5 is the biggest we could get.
And it sees a 5.
It sees a 5.
So the most it could be is 4.
4.
And it can't be 2 or 3.
Yeah, because it sees 2 in the row and 3 in the box. So this is a 1 or a 4.
If it's a 1, it can't go with a 4 because that would give us 5.
5, yep. So
if it's a 1, it could be 6 and
7.
It couldn't be 7 and 8. So if
Correct.
it's a 1, it's a 6.
And if it's a 4, it can't be a 7. So this can never be a 7. So we either have 1 and 6
or 4 and
to
4.
make 7.
And it can't be 4 and 4 to make 8 because
Yep,
there's an 8 in the column.
Yep, so this is 1. It's very nice. I'm glad you thought we should look at that because that helped considerably.
That clean up the ones.
It will clean up.
8.
Yeah, let me do a bunch of cleanup. So that took the 7 out here, which also takes the 7 out at the other end of the palindrome. Takes the 7 out on this arrow, which takes 8 out from the circle. And this one removes that 1 from the row and places a 1 on the tip of this arrow.
Which takes the 5 out.
Which takes the 5 out because we can only have 1 plus 7 is 8 or 1 plus 8 is 9.
There is an 8 in those two.
Ah, yeah, nice. There's an 8. Okay. So now. Oh, this 9 has been for some period of time looking down and giving us 7s on that.
Which makes the circle in box 1 of 4, which makes it a 1-3 pair.
Okay, you're jumping over in box
1.
Okay, okay, 4, yes. Which makes this indeed a 1 clicks. Okay, that's a 1 because the 1 there's a 3. There's a 1 already in column 1, and that's a 3.
Resolves the 3, 4 on the palindrome.
Yes, because that can't be a 3. Those have to be 3s. We also get where I was looking, and this is why I was confused when you were starting to talk about arrow circles, is that this 7 also comes places an 8 there, which places a 9 there, which means we need an 8 to complete the arrow sum, and that the 8 and the 9 both look in and give us a 7 here, which takes 7 off of this palindrome. Oh, and the 4 in this circle makes those both 8s.
Which makes the arrow a 6.
Yep, so this 8 makes that a 6. 6 plus 1 is 7. This is beautiful. This is just beautiful construction.
Okay. Should we pencil mark box 9?
Okay, I was going to do rows 3 and 6 first, but we can pencil mark box 9. That's fine. So we have 1, 2, we're missing 3. We've got 4, we're missing 5. We've got 6, we're missing 7. We have 8 and 9.
There's 5, 7 in row
5
7.
and 7 makes that a 3. And then we have a 5, 7 pair.
Okay, so row 6.
So now row 6. Or row 6, okay, I can count. We've got 1, 2, 3. We're missing 4. We've got 5, 6, 7, and 8. Yes, 4 and 9. And row 3, we've got 1, 2, 3, 4.
5 and 9, but it's placeable.
It's 5 and 9, yes.
9.
We've got the 6, 7, 8. Yes, we're missing 5 and 9. There's a 5 already in this box, so we place the 9, which gives us the 5. And the 9 looks down, gives us the 4 and the 9. So box 4, we've got 1, 2, 3, 5, 6, 7, and 9. So yeah, 4 and 8. Column 7, we've got 1, 2, 3, 4, 6, 7, and 8. So this is a 5, 9 pair. Which means that this then is a 6, 8 pair, and that's placeable because the 6 looks over and gives us an 8 and a 6.
The 8 looks across to
8 looks over, 4, 8. So that must mean from this row, unless I've forgotten to eliminate something, which happens, that that's a 5, 9. And in the box, 1, 2, 3, 6, 7, 8, we're missing 4, 5, and 9.
And now row 7, maybe?
Row 7, yes. We've got 1, 2, 3, 5, 6, 7, and 8, so we're missing 4 and 9.
Gives us 4, 5, 9 triple in column 4.
Oh, nice. So we've got 1, 2, 3, 4, 5, 8, and 9. We're missing 6 and 7. There's a 7 in box 8. So this is a 6 and that's a 7.
That places 7 in box 1 by Sudoku.
7 cannot be in those. Places a 7 there. We know that 2 has to be in this upper corner. We said we were going to keep track of our 1, 2, 3 being up here. And that places on 1 spot left for the 6. And then in this column, we've got 1, 2, 3, 4, 5, 6. We need a 7.
Which resolves the 5, 7 in box 9.
It looks over 5 and 7.
Box 3 maybe?
Box 3. Okay. We're missing 1 and 2, placeable. 1 and 2. This 2 looks over
and then
to...
we need an 8 in row 1.
Yep, we need an 8. And then we need...
4 and 5.
4 and 5. All right.
Check my...
Oh, yeah. 1, 2, 3, 6, 7, 8. Yeah, 4 and 5. This 9 is looking down to give us a 4. which gives us the 9, and the 4 looks back up to give us the 5 and the 4. The 4 looks down. We now have a 5-9 pair in box 5, giving us a 4 at the center of that palindrome. Center of the palindrome, so we can't bump it out to place anything else. But
6 maybe.
well, I was actually thinking that this 9 in column 4 looks up and gives us a 5 and a 9. 9 gives us the 5 and the 9.
So we'll do Sudoku.
Yeah, sure, yeah, Sudoku and a Sudoku puzzle. Let's see, 1, 2, 3, 4, 5, 6, 7. We're missing an 8.
4 and 5. No, 5 and 3.
In this box, yeah, 1, 2, 3. 1, 2. We're missing 3, which has to go here because that 3 is looking over. 4, and then that's a 5. In this row, we've got 1, 2, 3, 4, 5. Yeah, we 6 and 9. So that's the 6, that's the 9. And then we have a 2, 4 pair. The 4 looks down, gives us the 2 and the 4. That was so much fun.
That was a lovely puzzle.
That really was.
Even if it didn't have outside clues.
Even without the outside clues, the getting started, the interaction between this arrow, so what that did to this circle, bumping down to being on an arrow and bumping up to this circle, that was just spectacular. And then that's those 1, 2 pairs sort of everywhere, forcing the 1 and 2 into this spot. And this arrow too, the way this played into this chain of arrows was just stunning, just absolutely stellar setting. Thank you so much, Maggie. Thank you so much, BremSter.
Indeed. Thank you so much.
Such a delight. And to all of you out there watching, if you haven't already subscribed to BremSter's channel, we really encourage you to do so.
Please like the video. It helps with his stats for YouTube.
Very much so. And good luck with your solving, in Brem's words.
Yes.